Welcome back to Wildcat Academy. Today we'll be learning about factoring polynomials using the sum and difference of cubes formulas. So the sum of cubes formula, you start with a cubed plus b cubed, and so we want to first identify our value of a and then b by taking the cube root of a cubed and the cube root of b cubed. This will allow us to identify a and b. And then I don't usually use the formula from that point forward when I'm working the problems. I just look at a and b, and I will go and I will think a times a gives me a squared, a times b gives me ab, and then b times b gives me b squared. And then I'll go back and I will sign the terms according to the acronym SOAP, same, opposite, always positive. So let's take a look at example 1, and we will identify our a value and our b value by looking at the cube root of x cubed. So the cube root of x cubed is x, and the cube root of 8, which is also can be rewritten as 2 cubed, is 2. And that creates our binomial, and now we'll need to create our trinomial, but I just look at the binomial to do that. So I think x times x, which gives me x squared, 2 times x, which is 2x, and then 2 times 2, which is 4. And then we use the acronym SOAP in order to say same, opposite, always positive, and we're finished. So now let's take a look at another example, example 2. So we will once again think about our a value and our b value here. So we were wanting that to be, that's 10 cubed, and we can look over here at our perfect cubes to recognize that 1000 is a perfect cube. And then we will just begin with our binomial. The cube root of x cubed is x. The cube root of 10 cubed, or 1000, is 10. And then we'll use our simple formula to create the trinomial. And I usually do that from the binomial once again. So I'm going to go x times x, which is x squared, 10 times x, which gives me my middle term of 10x, and then 10 times 10, which is 100. Then once again, use the acronym SOAP, same, opposite, always positive. The same as my original problem, opposite of my original problem, and then this last term will always be positive, so it is addition of 100. All right, so these problems were very straightforward, single term, no variables in the second term, no coefficients. Let's look at something that's a little more complicated. Okay, so example 3, we're going to go through the same process that we were just looking at. We're going to take the cube root of this first term, a cubed, that's 2x cubed, and this one is 3 cubed. So when we take the cube root of them, we get 2x and we get 3. It's not necessary to write this above. I'm doing that just for a visual so that everyone understands. When we take the cube root of 8x cubed, then it becomes 2x, and the cube root of 27, which is 3. Then we say 2x times 2x, which is 4x squared, 2x times 3, which is 6x, and then 3 times 3, which is 9. And then we will sign according to SOAP, same, opposite, always positive. All right, and example 3 is finished. All right, example 4. So once again, we'll have 5x raised to the third power, and then 2y raised to the third power gives us 8y cubed. These are already perfect cubes, and that creates the binomial 5x and 2y. And then our trinomial is created from it. 5x times 5x is 25x squared. 5x times 2y is 10xy, and then 2y times 2y is 4y squared. And then we'll make our signs according to the acronym SOAP, same, opposite, always positive. So there's 4 quick examples on the sum of cubes. The difference of cubes is going to follow the exact same pattern. So let's take a look at it. So the difference of cubes, we have a cubed and b cubed. Only difference between the sum of cubes and difference cubes is the word difference, and you see there's a subtraction sign between them. So you can see if we take the cube root of a cubed, we get a. The cube root of b cubed is b. And then we will take a times a gives us a squared. A times b is ab. B times b is b squared. And then it is same, opposite, always positive. So just a quick example here. Very straightforward. No coefficient of x cubed. And then a perfect cube already with 27. So we will take the cube root of x cubed and the cube root of 27. So that will give us x and 3. Then we will take x times x, which will give me my first term, x squared. X times 3 would be 3x, and then 3 times 3, which is 9. And then we will sign this according to SOAP. Same, opposite, always positive. Now the only difference between x cubed minus 27 and x cubed plus 27 are these 2 signs right here. In x cubed plus 27, it would be plus, and this would be minus. The whole other process is exactly the same. Now, something a little more difficult. We have a leading coefficient of 8 on our x cubed. So we will still perfect cube. That is just 2x cubed. This one is 5 cubed. That gives us 2x and 5 in our binomial. And then we create our trinomial by 2x times 2x, which is 4x squared. 2x times 5, which is 10x. And 5 times 5 is 25. And then we will sign according same. Whoops. Made a mistake there. Correct that right quick. It'll be same, opposite, always positive. And I just repeat that to myself as I'm learning this. It helps ingrain that, and we know the pattern, we know that repetition, so that eventually we won't have to use that acronym. We just know the signs, and we can write them as we factor. Okay, so example 7. We have variables and coefficients in both terms, but still both perfect cubes, 27 and 125. That gives us 3x cubed and 5y cubed. So when we take the cube root of those 2 terms, we will get 3x and 5y. Then we'll simply say to ourselves, 3x times 3x gives me 9x squared. 3x times 5y is 15xy. 5y times 5y is 25y squared. And then we will have same, opposite, always positive. Process is completely the same. A little bit more difficulty in squaring 3x and squaring 5y. That's a typical mistake, is that when you square 3x, students will write 3x squared. They will forget to square that coefficient. So just be careful that you do know that that 3 is squared and it becomes 9x squared. And the same process would happen for 5y. All right, so number 8. This problem has a GCF, so it masks the perfect square coefficients. So we still know that this is going to be, or suspect this would be sum of cubes or difference of cubes when we're starting this problem, because we have exponents that are multiples of 3. But we're not currently seeing our perfect square coefficients. But we have a negative out here in front of the leading coefficient, which we never want to try to factor with that negative out front. So we want to go ahead and we know we're going to factor out that negative. We're also going to factor out a 2 because 16 and 54 are divisible by 2, and that will give us an 8 and a 27 for those 2 terms as coefficients. So 8x cubed and 27y cubed. And I've made a mistake right there unintentionally, so be careful that you don't make a similar mistake. When you factor out a negative, make sure you flip the sign of both terms. So the first term was negative, it becomes positive. The second term is positive, it will now be negative. and this becomes the difference of cubes. So we go ahead and bring down that coefficient, we make space for our binomial, and then we will create the trinomial from it. So that becomes 2x and 3y, and then we will square the first term, 2x times 2x, which is 4x squared. We'll multiply the combination, 2x times 3y, which is 6xy, and then we'll square the last term, 3y times 3y, which will give you 9y squared. And then we just sign it, same, opposite, always positive. Alright, so that winds up our examples for sum and difference of cubes. I hope you enjoyed the video. If you did, be sure to press the like button. And if you haven't already done so, subscribe to the channel and look out for more great videos from Wildcat Academy.